Hello, good afternoon, good evening, good morning, wherever you're from. Welcome to another episode of OpenShift TV. This is a very special ad hoc episode, joined by the one and only Matt Dorn and Edmund. I can't say your last name. I forgot to practice it first. My bad. Um, Feel free to say it now, though.
Yeah,
Uh,
it's a Ching.
Edmund Cheng, thank you. Sorry, I've late in the day I forgot to do that last producer check thingy. But yes, welcome to the Operator 1.0 show, Operator SDK 1.0. I'm joined by Matt Dorn and Edmund Ocheng. Edmund, please introduce yourself to everybody.
So, as you've heard, my name is Edmund Ching. I'm part of the operator enablement team at Red Hat. So, my role basically involves interacting with partners who are working to build an operator and help them figure out the right way to do it and help them along the way whenever they get into or they run into hurdles. So, that in a nutshell is what I do.
That's awesome. You have the coolest job.
Thank you.
Matt, how's it going, buddy?
Good. How are you doing?
I'm doing great, buddy. You want to introduce yourself to everybody?
Yes. Hello, everyone out there. My name is Matt Dorn. I'm an engineer here. I work with Edmund on the operator enablement team, do all the same things that Edmund is talking about. We help people like you. We help our partners. We help customers, everyone, understand this thing called operators and how they can utilize the operator framework to make life easier.
And that's what we're all about.
Yeah.
Technology should
That's
make
it.
human existence better, right?
Yes.
Like
That's the idea.
that's the idea, at least, right? Like we
Yeah.
hope that's the outcome. So yeah, like operators have been part of my entire like Red Hat career. You know, not that I've been here forever, only 2 years now, but like when I first joined the Ansible team, they were like, "Whoa, you know Kubernetes? You should work on this thing we're doing with Ansible and operators." So Matt and I have kind of worked back and forth with each other on and off the entire time I've been here at Red Hat. So it's great to have him on the channel today. Edmund, your team has done amazing work, and I'm very proud that you're both here on the 1.0 show, essentially, for lack of a better term. So, what has happened in the Operator SDK to make it 1.0?
Well, quite a bit has changed. And, just the fact that it's 1.0, I believe, is a big milestone. It means that we've figured out how operators should work. And, that alone is good reason to celebrate. And the second thing is with Operator SDK v1, we switch from our old scaffolding method and we adopt the Kubebuilder v2 format.
Beautiful.
And that was very critical because some of the tools that we used to scaffold operators in the past were being built by Kubebuilder. So it didn't make sense for us to have a competing product.
Right.
And I think that makes it critical for us to merge. And at the end of the day, all the commits and additions that both the teams put together are able to come together and build a powerful product. So it's a wonderful time. No reason not to celebrate.
There's absolutely none, because I remember sitting in San Diego last year talking to the Kubebuilder folks about how like this should happen, and like we're duplicating efforts. Well, why are we doing this kind of thing, right? So like this is huge and all the reason to celebrate. Absolutely.
Yeah. And the other thing is also with the merger of the two groups, the community also becomes one,
Right.
because at the end of the day, when you're doing open source projects, the community is very critical. Once you have a segregated community or a community, the speed with which the projects move is a little bit reduced. So
Exactly. We don't want that.
yeah, not at all.
So Matt, you had some things you wanted to share with us real quick or anything?
Yes. So Edmund and I are making some assumptions here. We're going to assume that we probably have a mixed bag in terms of the people that may be tuning in right now.
That's a safe assumption.
We probably have some people here that maybe have heard about this operator thing and are trying to learn more. We probably have some people who have used the SDK before 1.0. Maybe you used an older version. Maybe you played around with it when it first came out. Maybe you built a project and you have an existing operator that is public that you built was something pre-Operator-SDK 1.0, and you're wondering what all the changes are. How hard is this going to be for me to actually migrate or upgrade? Well, we're going to do some level setting, and we're first just going to basically talk about what an operator is. We always kind of like to do this to eliminate any of the confusion, because it's totally possible that you're tuning in here and you just need to know the basics for right now. So before we get into like the hard stuff and start playing around with the code, we're going to share out a few slides and just kind of give you a brief introduction before we start getting into the fun stuff. Does that sound good?
Sounds good to me. Let's let it rip.
Cool. Okay. So let me go ahead and share out the screen. All right. So we should have you should be seeing the introducing Operator-SDK 1.0
yes, sir.
on our screen here. Okay, great. And then what we're going to do is we're going to go ahead and let's go ahead and do it. Okay. So just so you know, for those of you that are learning to all this stuff, if you go to learn.openshift.com/operator-framework, we have a variety of exercises on there so you can learn about this. Now, here's the thing. This session right here, we're going to do a live migration. Edmund and I are going to show you a live migration from the Go-based operator right here called the Operator-SDK with Go. It's called the pod set operator. We're going to upgrade that to 1.0. And then after we're done with the session, we're going to push all the live exercises that are all on 1.0 to this area. So we're doing this so in case you're watching, right, and you're tuning in and you want to see what a live migration is like, you can use this old pre 1.0 project right here and follow along with us and see if you can get it upgraded to 1.0. We'll show you that there's a couple things that you have to kind of keep in mind, a couple hurdles you have to get over, pitfalls, things like that. But after we're done with this session, this will all be upgraded on the new stuff.
I literally cannot wait to learn how to do this.
Yep, it's going to be cool. It's going to be cool. Okay. So like we said before, we're here to help you succeed with our tools here. So we're going to be talking about the operator framework. What is the operator framework? The operator framework consists of basically the Operator-SDK, which is your software development kit to ease the development of creating an operator. And you may think, why does something like this even exist? Can't I just use the client library like Client Go directly? Sure you can. You're free to do that. But doing so is very difficult. There's a lot of hurdles to jump over. And you have to have very, very, very in-depth knowledge to use something like that. There's not a whole lot of documentation on Client Go. If you're wondering about Client Go, basically written in Go, you may be familiar with Go or learning more about it. There's a lot of great resources out there. This is a client library that enables you to programmatically interact with Kubernetes. So you'd have to use that directly in order to build your operator. With Operator-SDK, far, far, far behind the scenes, underneath all the abstractions, it is using Client Go, but it's a very easy way to create an operator without having to utilize the Client Go directly. And as Edmund and I are going to show you, there's a whole lot of variety of tools that you get with it. Operator Lifecycle Manager is basically responsible for once you're done developing your operator, you're all done, you put in the hard work, you spent months and sweating over it and just like coding all night,
battle testing, yes,
all that stuff. You have to be able to install it, right? And you got to be able to manage it, because the reality is you're going to be upgrading from V1 to V2, you're going to be bumping it, you're going to find bugs. How are you going to take care of all those dependencies? And by dependencies, we're talking about, think about it. You're not running this thing probably with a default service account. You're probably going to run your operator with a special service account. That special service account has roles. Then you have role bindings. And then you have custom resource definitions, which we're going to show you about coming up here. There's a whole lot of stuff, right, that go into actually ensuring an operator is running properly on the cluster. So that's what Operator Lifecycle Manager takes place. It takes care of all that stuff for you.
Good.
And by the way, as Chris will tell you, this is all operator framework. Donate it to the CNCF, right, Chris?
Yes, absolutely. Just a couple months ago, we donated to the CNCF. It was months in the making. Finally did it. Thank you to the efforts of Diane Mueller, Aaron Boyd, Daniel Messer. It's in the ecosystem officially, and it is a real CNCF open source project. This is not something just out of Red Hat. We've donated it to the greater community for everybody to get the benefit of.
Gotcha. And just for some people that may not know, why would I feel more confident working on a project that is basically now under the CNCF when it has that seal of approval? Why would I feel? Right. Why would I be like, well, I'm gonna work. Maybe I'll contribute to this more. Put more effort into it. Maybe use it. Why do I feel more confident?
So let's back up and define what CNCF is real quick. Cloud Native Computing Foundation. I am a CNCF ambassador. Part of my job is to tell people what CNCF does. So this is perfect. CNCF is essentially the IP management wing of Kubernetes and its ecosystem. So when Google and Red Hat and everybody got together and was contributing to Kubernetes at the time, and they were like, what do we do here? Well, let's give it to the Linux Foundation. Linux Foundation stood up CNCF, put the intellectual property for Kubernetes and, etcd, everything else that kind of makes up that Kubernetes infrastructure into the CNCF so that everybody could benefit from the upstream contributions of the entire community. That's 20,000+ people now, like over 100,000 people in Slack last I checked. But yeah, it's a massive community now. And if the CNCF says, yes, this works with Kubernetes, that is a seal of almost guarantee that you have that this thing works with Kubernetes and works within this cloud native ecosystem.
Cool.
And I think another aspect to that, not to dispute what Chris is saying, but I think the fact that you have a neutral party saying this works also gives you legibility or credit to a product to say this is not being driven by the selfish motives of a particular company, but it's open to be driven by the community and what the community wants. So
exactly, this isn't github.com/Red Hat/ something. This is github.com/operator framework. This is the project. Yeah.
Yeah, very good points. Yeah, very good points. And all this stuff, just so you all know, I don't know if I mentioned it, but yeah, this stuff is not I mean, when you install OpenShift, you get Operator Lifecycle Manager installed, but it runs on vanilla Kubernetes. It runs on upstream Kubernetes. Any distribution that you may have, it runs on there. And we'll talk a little bit more about that coming up. So what is an operator? What is an operator? What's the definition? Well, the formal definition of an operator says that an operator represents human operational knowledge and software to reliably manage an application. But it's kind of vague, what are we talking about here? Well, to really understand the origin, we go back to November of 2016. This was a blog post, that's what you're looking at here, from Brandon Phillips, the CTO of CoreOS. And if you're not familiar with CoreOS was a company, first of all, acquired by Red Hat in 2018. And they were responsible for something called Container Linux. And Container Linux was an operating system, very, very popular at the time, which basically sole goal was just to run container workloads, right? It didn't have like a package manager on there or anything like that, right? And so it just ran, and it was totally secure because it had auto updates turned on by default. It really awesome. It actually was very similar for those of you tuning in that are maybe familiar with Red Hat Atomic, right? Atomic. It was kind of similar to that. But they were really heavily invested in Kubernetes. That's the point. They started getting heavily invested in Kubernetes. And Brandon comes out with this blog post where he goes, today we're introducing this brand new term called operators, a class of software that is for Kubernetes. So it's software for Kubernetes, but it takes on 3 aspects. This is what makes it an operator, okay? The first is that it's a resource. It utilizes, it utilizes a resource. Specifically, it utilizes a custom resource. So for those of you who use Kubernetes, and we'll show you here coming up, you have things like pods and config maps and all that stuff. Well, an operator uses your very own custom resource, one that you created yourself. Like it could be called like imagine your name, or let's just imagine we call one called Red Hat or whatever. you create your very own resource. What does that mean behind the scenes? Your very own API endpoint. And guess what? You don't have to even bring down the code and add that new type and recompile it. This is literally you sending an API call to the API to create that custom resource. So you could think of things like maybe MySQL or your application, or anything you can think of, a custom resource for Kubernetes. So it uses this thing called a custom resource. It utilizes a thing called a controller. And for those of you who don't know, controllers run Kubernetes. There are tons of controllers running concurrently at Kubernetes at any given time that you may not even know that you are experiencing in real time. Like, for example, when you create like a replica set, right? Which with the replica set, you put the number of pods that you want to spin up. That's a controller. That's a controller called a replica set controller that's watching the API. It sees the creation of the fact that you want 3 pods, and it makes the necessary changes to do that. And then it's also it also has application specific knowledge, right? Which basically means that this is knowledge that only you know about your application, like all the ins and outs of your application that you deploy on Kubernetes, maybe any of the manual intervention that you do with your application, maybe it's strict guidelines for the way it spins up or scales out or backs up. All of that stuff is going to be codified into the operator itself. So it's handling all of these kind of site reliability engineering type tasks that you would typically have an engineer do or an SRE do, but it's codified into the operator. So it utilizes a custom resource, it's a controller, and we're going to build all these things today and show you, and it has operational knowledge. So we talked about what a resource is. We're talking about things like pods. You all know what pods are. They're the fundamental unit of Kubernetes. Things like a pod can have 1 container or multiple containers. We know that containers in a pod share the same host name. Containers in the pod share the same network stack. It's really that fundamental unit that we interact with for deploying our application, right? And then, of course, we have the config map. You may have some application data, like a config file, a comp file. You may want to map that to a pod. That's what the config map provides, a way of abstracting that content and then mapping it to your container or pod, right? And then, of course, router ingress. For those of you that maybe are tuning in that may not be familiar with OpenShift or are more like upstream Kubernetes people, understand that route and ingress, very similar. We're talking about a way of getting access to your application now that it's running in your cluster. How do you get access to it from the outside world? You do that via a route or ingress object, right? So you can get to it via here, like a saying, like by a website address or something like that. So these are all resources. So the operator uses a custom resource. An operator uses your very own resource. So on the command line, if you were to say kubectl get, I don't know, my resource, it would be hitting an API endpoint that you've actually created that represents your application. And then we talked about controllers. Replica set was an example I just mentioned, but other examples of controllers are things like daemon set controllers or deployments or things like that, right? These are things that are running in the cluster. They're watching the API. And when anyone makes a change to the API, modifies that object or does something to what it's watching, whatever resource it may be watching. For example, the controller is watching your custom resource and a user comes along and changes some values in that custom resource. The controller is going to react to that. The controller is going to receive an event, and then it's going to look at that resource, what the user wants, and compare that to what is. Does what the user want currently exist in the infrastructure, in the cluster? And if not, it's going to make all the changes to do that. And this controller gets triggered, right? As Evan and I will show you, we actually go and create a controller with the new Operator-SDK. It gets triggered anytime this resource is created, updated, or deleted. Created, updated, deleted. That's when this controller would get triggered. And again, things like the replica set controller, the deployment controller, these are all controllers built in to Kubernetes. The daemon set, which ensures that a pod is running on every node in the environment. You're going to build your own controller. And then, of course, last but not least, knowledge, domain-specific knowledge. This is all. This is. You might even wonder, they always ask us, What should we make our operator do? The answer is, it depends, right? It really depends on what your application does and what are the pain points, right?
Right.
What are the pain points? What are the
What
pain
problems
points?
are you trying to solve, right?
Right. Exactly. What are the things that wake you up in the middle of the night? What are the things that you're manually doing, right? The things that you manually have to do. That's what we're gonna codify, right? So not just installation, and you all know installation is pretty easy. You can do a kubectl apply. You may be using Helm and do a Helm install. Installing is pretty easy, right? You're setting everything up. But we're talking about things like self-healing. What about in the middle of the night when something happens and a database gets corrupt? What happens when something's no longer responding? We need to react to those changes. What about scaling? I don't just mean blindly scaling out like you do with a stateless application like a replica set. You know, when you scale up a replica set, it just blindly spins up like, right.
However many you want. Yeah.
Right.
It just goes nuts.
Right. Exactly. What if your stateful, let's say you have a stateful application, and I like to point out that operators aren't limited to only stateful applications. But let's say you have a stateful application like a database or something that can't come up in just a random order because it has to first be very careful and delicate and fetch some state information, maybe from a PV residing on a node. Then it needs to come up. It needs to talk to its peers in that cluster. Maybe somebody has to become a leader. There might be some consensus algorithm, like that sort of thing, right? That's the sort of thing that we are going to codify into our controller, right? That sort of stuff. It might have to scale in a particular way. We talk about updating. We're talking about updating the application and may need to be updated in a very graceful and special way. And when we talk about updates in the world of operators, we're not only talking about your operand or the application being updated, but we're talking about what happens when you introduce a breaking change to your custom resource. There's a reason why Kubernetes is built on this whole V1 Alpha 1, V1 Beta 1. You know how APIs
Thank you for bringing that up.
Yeah. It's just, very, very, it gets confusing sometimes, right? People, all these different versions. Well, it's because things grow and change over time. And when you introduce a new change, for example, like introducing a new key value inside of a spec section for an object, like now you have this cool new feature that allows you to actually track something or do something, you're gonna have to bump up the version, right? So not only are we bumping up the actual custom resource, but then we're also bumping up the operator. We're up the operator itself. What about when you get a bug in your operator and it doesn't respond to something right and you got to push out a new update? And then backing up, meaning storing offsite backups, cleaning up. You get the idea. Observability, we want metrics. We can utilize Prometheus to do that, resiliency, all that good stuff. So that's just a really quick summary, right? Resource controller knowledge, that's an operator. That's an operator. And I think we're going to talk a little bit now about Operator-SDK 1.0 before we get into our actual coding. So I think we have, just to kind of show everyone, and Edmund, you can kind of too, I'm going to show everyone this kind of, I think it might be important to kind of show this real quick, just so you all can see this. With Operator-SDK, this is sort of the old way it was. This is the way it was before, right? Before. Now, this is pre 1.0. Edmund, do you want to talk a little bit about the kind of our layout here and what these things are, like for people that may not know, like what controller runtime is and things like that?
So it might be quite difficult to explain, or it requires quite a bit of information. But so client Go would in most cases be what would allow you to interact with Kubernetes and in a programmatic way. So interacting with Kubernetes APIs, getting a client to interact with all the different resources. You will have access to, let's say, the different groups that you have under Kubernetes. So for instance, if we think about our resources, we've mentioned pods, services, secrets. Those would be within the core group, and core group is V1 right now. So you'd be able to access core V1 and say, I want to go into, or I'll get a client and I want to interact with core V1. I want to get a list of pods or something of the kind. And controller runtime would sit on top of client Go and give you some functions that you'd use to interact with the different objects. So for instance, you may have a get function, which would have interfaces behind it and all that, so that you can use the same function to interact with your deployments, your pods, and all these different resources. So most of the tools just build on top of each other. But with Client Go alone, you may be able to interact with Kubernetes even if you don't have controller runtime, but it does make things easier for you. Yeah, so that would be in a nutshell what Client Go and controller runtime are. The other controller tools would be tools that would allow you, for instance, to generate CRDs by creating your type. So for instance, it may make more sense as we go deeper into the hands-on section, but as you create resources, some of the resources you need would be auto-generated. So your controller tools come in at that point.
Exactly right. So what we're going to learn is, and again, we probably assume maybe some of you know what are very familiar with CRDs or custom resource definitions are, and some of you may not know, but understand that a CRD is a representation of that custom resource definition. That's the object that we're actually going to send an API call to the API to create that custom resource endpoint. Now, when you go and we'll open it up and show you, when you go and you create a custom resource definition, there's a whole bunch. And let's actually, what I'm going to do is just pull this up in the Kubernetes, on the Kubernetes upstream documentation. Kubernetes custom resource definition, it should come up. I mean, we can actually put, let's see, we can put validation. I think that might help come up. Yeah. So for those of you that aren't familiar, and I'll drop this in the chat.
Thank you.
The Kubernetes API, the custom resource definition object, which is right here, which is actually how you create your custom resource definition. There's a whole bunch of stuff that you can actually put inside here where you define what you want allow your users to do. Like you can put validation information, as Evan was just telling you, you can put minimum and maximum. Let's say you want your users to like only put in like a minimum, maximum, like you say, minimum of 1, maximum of like 10 for like number of replicas. You can put all that validation information into your CRD. And if you imagine editing a CRD itself or editing a CRD manually is like a real big hassle, right? It's like, if you can imagine having to put all this, like, I mean, this is a very small one, but if we look at like an actual real world CRD, and if I go to community operators on GitHub, right, and I look at something like the Argo CD operator, which if you all haven't used Argo CD, you should definitely, people watching, definitely check it out. It's great for GitOps. Look how, let's see.
GitOps project, yes.
Yep. Check out this, how big this custom resource definition is. This custom resource definition represents Argo, represents an Argo CD object, okay? An Argo CD object. So this is a custom resource that once created, a user would basically be able to go and on the command line, be able to do, for example, kubectl get application. Now, prior to installing this, there is no such thing. The cluster won't know anything about it, right? But after this gets created,
called application in Kubernetes.
Exactly.
Yeah.
Right. Yep. Exactly right. Yep. But look how big it is. Look how huge this is, and this is all validation information, right? This is all the predictability and of the schema. It's the schema of your object, and
that's years of knowledge right there.
Right, it's a lot of stuff. Exactly. So with those controller tools, which we'll show you coming up, we're going to play with them, that Evan's talking about. You can put special markers in your code where it will automatically generate all of this stuff for you. So while you're coding and you're building your types, you put the markers in, you run a command, and it will automatically generate all this stuff for you. It makes it much more cleaner, so you don't have to worry about, you know, am I putting the spacing right? Am I doing, you know, this is, you know. So the controller tools are really helpful in that direction. Now, what I'm showing you here, I know it's a lot of typing on here, but for those of you who are tuning in, who are familiar, This is for those who are tuning in. This is the workflow. This is like the basic workflow for Operator SDK before it was released. I'm sorry, before 1.0.
Right.
Before
Correct.
1.0.
Yeah.
And if you go check out our exercises at learn.openshift.com/operator-framework, just to show you, opening it up again, learn.openshift.com/operator-framework. And you go to Operator SDK with Go. And this will actually, you'll walk through creating this thing called a pod set operator, which we'll talk about in a sec. But the point is that the overall workflow, this is an example of the workflow, okay? And you can see the workflow here is you would run this Operator SDK new create app operator -- type equals go. Let me ask you this, Edmund, do you think, Edmund, do you think anything you want to add? I think maybe we can walk through the old flow real quick, and then we'll point out, then after walking through the old flow, we can maybe point out all the new things in 1.0, and then we'll actually do a new scaffolding.
Yeah.
You think that sounds good? What do you, yeah, does that sound good?
Sounds fun. Yeah.
Yeah.
Okay, cool. So actually, why don't we go ahead just to show you how this works? Let's just go through the old one just so you can see that first and see what's changed. So in this case here, we're going to create a something called the Operator SDK with Go. It's something called a pod set, right? And just showing you what the pod set operator actually does. We have just a quick kind of introduction to what it does. It's a simple controller that manages pods. So what this does is when you create this kind called a pod set, and that kind pod set, it's a custom resource. So just like Chris was mentioning before, right? Mm-hmm. If you try to say kubectl get pod set or kubectl get what the custom, it's not your cluster isn't going to know. In order for your cluster to know, you have to create a custom resource definition. And this is going to be something that kind of mimics, this thing that we're going to create here is something that kind of mimics the replica set, right? It's not as like sophisticated as a replica set, but it's still kind of a really good exercise to kind of show you, you know, how exactly, you know, what's going on behind the scenes, how a controller can actually manage pods. And you can see here that what you do inside the pod is you just, or inside the spec here, is you put the replicas and you put how many you want, and the pod set spins up that many. And then the pod names are the number of, are the actual names of the pods it currently owns, right? So it's pretty straightforward. That's the pod set operator. Now, for those who have played around with this, we're just gonna kind of show you here. And by the way, with the pod set operator, if you were to go and like, you know, change number of replicas to a different number, you want your controller to be smart enough to get that event, reconcile it, or trigger this thing called a reconciler, okay? And look at the fact that now it has to create one or have only one and do the steps necessary that make that happen. So if you change this to 1, your controller should see that and then delete the currently available pods and scale down to 1, okay? This is just a quick animation kind of giving you the, before we actually do this, just showing you what this is, your controller is actually doing. Now, this aspect of the way the controller works, just so you know, is still the same in the new Operator SDK. This concept has not changed, okay? So this is still the same in the Operator SDK. So, for example, you have a controller and your controller watches for pod sets, right? Which is a custom resource. And it watches for pods that are owned by a pod set. So what we do is we just have a user who creates a pod set object with the number of replicas 3. And what does that happen? What happens? The controller gets that event because the controller is watching the API. Once the controller gets that event, and don't be confused, these events are not the same as like, well, you know, when you do kubectl get events, you run that command get events, and like it gives you information about stuff. This is not a reference to that type of event. Just making sure we all know that because they're using the same word, event. But it gets an event, your controller does. It hits this thing called the handler, right? And what happens is your controller gets a copy of your actual object you created. It gets a copy of this declaration and it triggers this reconciler. And we're going to look at the reconciler when we look into our code. And once it gets that reconciler or triggers that reconciler, the first thing it does is it gets the actual state of the world. And if you can see what it's doing here, it's doing a client.list. And if you're wondering what that is, we're utilizing, remember Edmund talked to you about controller runtime? A group of, it's a library that basically eases the development of operators and uses client Go behind the scenes. Well, I should say controllers specifically, tools for controllers. This is just using an rClient.list to actually just say, show me all pods that are owned by this pod set. Now, if we're creating this for the very first time, the answer is going to be 0, right? But what we're really doing behind the scenes is just sending an API call here. We could be utilizing the local cache in our controller, or we could be utilizing, making a call if we wanted to directly to the API. But the point is we're getting the actual state of the world. And it's going to come back and it's going to say we have 0. And then your controller looks at that 0 and it does some comparison. It says, okay, well, I have 0, but the user wants 3, right? This is the declared, this is what we actually want. This is the actual state, this is the declared state. I have to create 3 pods, right? And then it will create a pod. The creation of that pod, because I'm also watching for pods that are owned, gets triggered, right? Causes this to fetch a fresh copy of my object, and so forth and so on. And that's the way that when you look at your controller logs, you constantly see them running. That's what's going on here. It's reconciling, right? It's reconciling. And so this is just a very basic example of how your controller works. For those of you who may not be familiar with this whole kind of controller concept, right? For those of you who may be familiar with it. What do you think? You think we should walk through the old way, or do you think we should, what do you think? You think it's worth it, or you want to, should we go into, what do y'all think?
There's probably a lot of people using the old way that know how to do it, right?
Okay,
and then there's probably a lot of people that are watching right now that probably only care about the new way, right? So,
okay. All right. Yeah, let's do that.
Let's just go with the new way, I think.
Yeah, let's do that. So, what's the deal? For a long time, and this ties into the new way. Why is this tied into the new way? Edmund mentioned that at one time, the big question that Edmund and I got a lot from folks were, what do people always ask us all the time? They were like, what should I use? Kubebuilder or Operator-SDK, right, Edmund?
Yeah, that becomes a very common question. And, at the end of the day, it depends with what are you trying to achieve? What is your skill set? There are plenty of questions, but it's a common question.
Yeah, and here's what Kubebuilder was like. So Kubebuilder, for those of you who don't know, it was released in 2018, right? And the reason we're talking about Kubebuilder here is what Evan mentioned. Now with Operator-SDK 1.0, we have alignment with Kubebuilder. So what was Kubebuilder like when it sat by itself as a project? Well, it only allows you to build an operator with Go. That was the most significant thing. As opposed to with Operator-SDK, it allows us to use Go, Ansible, or Helm, okay? Kubebuilder was created by members of the API machinery group and now has its own special interest group, AKA SIG, for Kubernetes. I think it's called the SIG Kubernetes. And it utilized, just like Operator-SDK, it utilized controller runtime, the libraries for creating controllers, right? And controller tools, right? Which allow you to basically generate RBAC and CRDs and all that good stuff. But it also utilized Make. I'm sure everyone, that's into computers, we know about the Makefile and how easy it allows us to run some short commands to do complicated stuff. Customize, right? Which if you're not familiar with Customize, it also comes from the upstream Kubernetes world. It's basically, think of it as allowing you to customize your Kubernetes YAML without having to use like a Go templating engine or any sort of templating engine. It's almost like you get the power of templating, but you can just use native YAMLs that are unedited or unchanged, and it accepts a whole bunch of different keywords that are just kind of native to Kubernetes. So it's a way to just like generate custom manifests on the fly, right? And this comes in really handy when you build an operator, and then you need to ensure that when you want to apply your manifest to the cluster, that they're reference the right namespace, they reference the right service account, they have the right RBAC and all that good stuff. So this was what Kubebuilder was like. And do you notice this? Like this was the workflow,
yeah,
the old
it
way.
looks vaguely familiar. Yeah.
Right. Yeah. You create an operator, you go and you basically add an API, you generate K8s, you generate CRDs. What we're doing is we're creating our very own API. That's what's the most significant thing here. We're running this generate K8s command, which, by the way, is actually using the controller tools behind the scenes, but we're not calling them directly. It's important that's changed, right? And also add controller, right? So here we're adding a controller, which adds the actual controller logic. And of course, you have to customize that yourself. It's not like it actually can read your mind and knows how you want to build out your operator. I mean, you have to put work into it.
Right.
And then obviously you want to test it locally first. And for those of you that are Go experts or love using Go, this is comparable. What this is doing behind the scenes is a Go run CMD. So this is just compiling your code and it's running it locally. And you could actually add to this, which is for those of you who may have even done this before, is you can actually add a kube config if you wanted to, and you can point it to your kube config, and then it will actually interact with your cluster. So it's the way you do testing to ensure the operator works. After the operator works, you then go ahead and you build your operator image, right? And then you're going to push it.
Yep.
And then you're going to install OLM if it's not already installed. We can do that really easily here. And then you create what's called a bundle for OLM. And you build your bundle and you push your bundle. And that's kind of like the packaging format that OLM utilizes. So you have this whole integration with OLM, with Operator-SDK. And you can create an operator with Ansible and Helm. And with this, with Kubebuilder, you can't, you're just limited to Go, right? And notice how the commands are a little different too, right?
Right.
So, just to interrupt you a little bit.
No, go ahead.
We just mentioned bundles for the first time, but we haven't really mentioned what bundles are. And I think a good analogy is if we think about our Linux systems for an example of to draw something to relate to. If you're running a Fedora or a system, I'll use Fedora for an example, you'd use DNF to install packages, and the package type it would install would be RPM. So in the same case, we've mentioned OLM would be responsible for managing your operator, so doing the installation and upgrades, and so bundle would be the package type that it would use. So the bundle would contain information of which images of the operator to install and what kind of permissions the operator needs to run and stuff of the kind. So once the bundle is pulled by OLM, it would set up the system to ensure the operator has resources it needs and then deploy the operator. So I think at this point you can continue so that, I just wanted to mention that so that if anybody hasn't heard about bundle before, they know what we're talking about.
Yes. And I appreciate you clarifying that. The bundle format, and by the way, if you're kind of curious too, what Edmund was talking about, if you want to see bundles, and specifically, look at this, when you go to OperatorHub.io and you see all these operators here, these are the representation of all of these operators. These are all bundles, right? These are all bundles, right? So you could actually go in here and install them into your upstream Kubernetes cluster. And if you want to actually see what these bundles look like behind the scenes, by the way, I didn't put in that other link. I have to do that.
I got it already.
Okay, cool. Okay. I forgot about that. Upstream community operators. Okay. If you want to see what these, it's right here, what these bundles look like. By the way, if you want to submit an operator to that OperatorHub.io, you just do so by making a pull request right here. So we can put, if you could, Chris, put a link to that, maybe folks can see what an actual bundle that Edmund was talking about here. Like, for example, let's look at the Azure Service Operator. Shameless plug. We're going to be dropping a blog post on this. This was just recently committed, but this right here is your bundle. This is your bundle. It's a representation here of this particular operator on 37. It's on 0.37. Notice what's inside there. A whole bunch of custom resource definitions. Okay. and something called a cluster service version, which is a creation. This comes from OLM, the cluster service version, right?
Mm-hmm.
And it's a representation, just like everyone was saying, of all of, it's a kind of a snap. I mean, the image that you see on OperatorHub.io is base64 encoded in here. Samples of what your custom resource should, like when a user wants to go and actually create something, this will automatically populate as to how their custom resource should look. A description of how you install the operator and how it works, and
Nice.
things you should know, right? All that sort of stuff is inside this cluster service version. But listen, we could talk about this for forever. So let's yeah, we can talk more about that for a long time. And also, okay, so what's new? As everyone will tell you, look, now Operator-SDK has the look and feel of Kubebuilder.
Mm-hmm.
It's aligned with Kubebuilder. So we have that kind of look and feel of Kubebuilder. So it uses the Kubebuilder plugin. Look at the commands. The commands are just like Kubebuilder commands, right? And notice that instead of running the Operator-SDK generate K8s, what are we doing?
Make manifest. Beautiful.
We're using make directly. And as Edmund will tell you, Edmund, it's pretty powerful to just be able to use make, right? Because you can edit the make file if you want to, right?
Correct.
Yeah.
And a good example would be, I think this week I ran into an issue where I was having the bundle validation fail because there was an entry that it wasn't expecting. And the good thing about having make is instead of creating a bug and waiting for it to be fixed before I can continue, I just went into my Makefile and added a sed and said, I want you to remove this value, and then run the remaining commands, and voila, my bug was fixed.
Hack the planet.
I didn't have to create a bug because I knew the issue had already been resolved in the master branch, but I did not want to go ahead and build my own binary. So I just did that. So that's a good benefit of having the Makefile.
Nice.
Yeah, exactly, right. And we also have customize now. So we can use customize for customizing our templates, which we'll show you here coming up. A new thing that what else is new? What else is new that we haven't talked about yet? Separate binaries for Go, Ansible, and Helm. Now, for those, remember the new command? It was always like new, and you do -- type equals Ansible or Helm.
Mm-hmm.
Now you're doing a init. And by the way, people always wonder, with this whole init command as the initialization, what is this domain thing that you have to append to the end of when you create a new project? Why am I putting a domain at the end? Well, for those of you that are familiar with the group version and kind, the GVK, we know that the group version, right, or the group is, pretty important, right? Because you have to make sure that domain is unique. Because think about this, like there might be multiple companies that develop, they're all racing to create the next MySQL operator. So you can probably bet that those companies are all going to probably use MySQL as like the custom resource, right? So how do we ensure that a user can install both competing MySQL operators that use a MySQL object? How do we distinguish between the two MySQL objects, right?
Yeah.
We can use a domain that is specific, like yourcompany.com or something like that. So this is really kind of setting the initial frame. This is kind of setting the initial scaffold to say this particular thing that I'm going to create is everything's going to be under this particular domain. And then look, support for webhooks is huge. Support for webhooks. Kubebuilder previously had support for webhooks, and if you are familiar with just thinking, how could I use a webhook for my application? What does that mean for webhooks?
Ooh.
A lot of cool stuff, right?
Yeah.
Yeah, a lot of cool stuff. So webhooks, aka admission controllers, or the admission controller in Kubernetes, and think about the name admission controller, like admitting. Are you going to allow this thing are you going to admit this object? What it is basically you have mutating webhook, validating webhook, or you have a CRD conversion webhook. And then what it basically allows you to do is when a user, like if Edmund goes and hits kubectl apply, and he wants to apply an object to the API, it will actually make a call to a webhook pod. In this case, it will make a call to your controller. Your controller is literally listening on a specific port, and you can write some code that will actually allow you to mutate or change the object before it gets persisted in etcd, right? An example of this would be like, for those you may be familiar with Istio, you know how you have Istio, it always puts like a sidecar, an envoy or sidecar pod when you create, you know,
that proxy there. Yep.
Exactly right. What if you wanted to have a proxy pod every time you wanted to create? You could use a mutating webhook to make sure that before that thing gets put in even etcd, it has a change to it. Or validating. Let's say you have some really, really complex validation, right? You can write some code in your controller so when it receives that request and the API gets that request, before it actually persists in etcd, go ahead and make sure it looks good or make sure that things are formatted properly. And then, of course, CRD conversion webhooks, which is for backward compatibility. That's more of an advanced use case, which we can talk about later. But webhooks are huge. And then, of course, customize, build, config, manifest. This right here is a command that is looking in a directory, config, manifest, which we'll look at coming up here in just a moment. And this directory has a customization.yaml. And it's making references to other manifests. And what this is allowing us to do is this will output, if you just run this command directly, it will output, as you've written or as you've requested, manifests like RBAC, your deployment manifest, your service account, maybe web validating and mutating webhook objects that are also customized as you like them, right? For the specific purpose of, you know, your cluster, you maybe you want it to actually, or a user grabs this code and they want to be able to output this. It might have a particular namespace, and make sure that it's basically so you don't have to go to each manifest and manually put in all the information. It'll allow you to easily customize your manifest to apply to the cluster. And here is where you can see we're taking the output from customize and we're generating a custom CSV or bundle, which Edmund talked to you about. And so I think that maybe we can start thinking, Edmund, do you want to, should we go ahead and show people the new, we'll do a live workflow on the new 1.0, and maybe just showing scaffolding a new project and what that looks like. And then we'll come back and we'll upgrade the pod set operator.
Yeah, we can go ahead and do that. I'm good.
Do you want to go ahead? Do you want to show that? Do you want to show?
Yeah.
The
I will start sharing my screen whenever.
Yeah, you can clobber.
I
should
can.
be able to.
All right.
Yeah.
And if for some reason you have an issue or it's like a good won't work or something, I'm happy to do it too. So whatever you want to do.
Okay. All right. Can you guys see my terminal?
Yes.
And
yeah.
Legible.
Hopefully
as
it's
well.
legible.
Very nice. Yeah.
Okay, great. So I just created a directory and it's basically called test operator. And I can increase the font if that is necessary. Just let me know.
I think it looks fine. If you can't see it in chat, let me know.
Okay, so in this case, I will do, let's just do some quick checks, right? What is that? So what Go version do we have here? I have Go 1.15.2. That doesn't matter, but you know, those are some of the things you may need. Operator-SDK version I'm running, we can say it's v0.0. v1.0.0. I think I said something else the first time.
Numbers are hard.
Yeah, they are. So with that being said, let's look at our directory so that we know I'm not doing any tricks. It's an empty directory. So one thing I want to do is, in as much as we may not push this upstream, I may want or to a code repository, I will just do a git init so that we can track changes as we go for it. So do a git init here, and so yeah, so we can do a git status and see what is changing as we go. So first thing, let's do a new operator, Operator-SDK, create, init, and I'll just do -- domain. And for this, I will say example.com. And that should basically generate an empty project. And we will have a few files which we can go through and see what's been created. But the main thing here is we're saying for all the resources or custom resources we create, we want them to have the domain example.com. And normally, for instance, when we create a resource, let's say we create storefront, that would be the resource, and we can say the group is enterprise, right? So it would be storefront.enterprise.example.com. That would be the full name of that resource. And let's do a git status and see what's been added. So here we can see we have a git ignore, a Docker file that we can use to build our image. We have a Makefile, which would give us those functionality that we've talked about, that would be in the make. We have a config directory, and I think I can just do this. Good old Linux commands and see the directory structure. So inside config, we'll have a bunch of directories that we can use to generate our different resources. And most of our customized resources or base templates would be in here. And then we have our hack directory that would have other assets like scripts that we may need when generating our resources, or whatever other special stuff you may have.
Why hack? I gotta ask. What series of decisions made that the directory name?
Yeah, that has been the naming for a very long time.
Wow.
And
Okay. Cool.
As far as
Yeah.
I've known Kubebuilder to exist, that directory has been present.
Brilliant.
And that's licensing information or something, right?
So in this case,
And that-
we have a license which is
Yeah.
going to be prepended in front of the code that you'd have. So whenever we have a new controller, we would see that we would have the same license information on top of that file. And yeah, I've had cases where I have resources that I want to exist inside my operator, maybe templates to generate configurations and stuff of the kind. I may create an assets directory and put it inside the hack directory, and then update my Docker file and say when building the image, I want this directory to be moved inside the container. Okay, so we can say, let's add everything. Normally, it's not a good idea to do git add this, but it's the first commit. I will do that and just say git commit -m initial commit.
You know, you're the second person I've met to say that git add dot is not great. But like, I literally find myself doing it all the time.
Yeah. So the main reason that it would normally be discouraged is sometimes
you've got multiple
For
files that are
instance-
in different states. I get
Yeah.
it. But
So for
like,
instance, if you have some files that you've deleted and you have some new files you've added, if you do a git add, the files that you deleted could be restored. And so you don't end up with the desired result. So it might be a good idea to go through and see, okay, what state is my file? And at the end of the day, let's say I may make a change and have multiple files changed, and I would know file XYZ are related to this change, and these other files are related to this change. So add those specifically, add a separate commit, so that if I want to revert a particular change, then I know I am reverting this commit hash versus having to break a commit and start, redoing the commit so that I can revert one change. So it just makes it easy from my perspective.
nice.
Yeah. Okay, so we created a new project, and when we did the init, we were told we can go ahead and create our APIs. So in this case, I'm thinking we can say we are an enterprise and we franchise out, and so for every new franchisee we have, we'll create for them a storefront. And so we'll do, we'll say our group is store. So we'll have, let's go ahead and create it and see how that looks like. Create API, and I'll just do dash dash help. Did I do it right?
One eye API.
Yeah. Well, like, yeah, that help doesn't look familiar. So Operator-SDK, create and I cleared everything. Great. Okay. So I'll just do it again so that we have the help information. So here we'll say we want to create the resource, which if we don't have it there, we'll get a prompt to say yes. So we can say we want a controller. And then the group we said would be store dash dash kind will be storefront. And I will say dash dash version v1 beta 1. All right. So that looks correct. Hopefully I haven't forgotten anything. And we create our new custom resource. And
So what did it, so when we ran that, what did it do for us?
So
what did it do for us?
That is what we're going to look at next, which is what has changed since our initial commit, right? So if we do, here we see we have some files that changed, and we have some files that are new that did not exist previously. So we can see we have our controllers directory, which is where we're going to have the controllers that will manage the custom resources that we'll have. And that's where we will add our application specific knowledge. So for instance, if we need to deploy, let's say Nginx, that is where we would create the code that says, we want you to deploy Nginx. And the CRD directory config CRD is where we would have generated content based on our API. So inside, if we look at the API directory, so I will do tree API. I seem to be very generous
Into extra
with my typing
vowels today. Yeah, you're buying vowels left and right.
Yeah. So if you look at this directory, we see we have a directory v1 beta 1, which is related to the version of the API we created, and inside that we have storefront as the type. So
but you can see the correlation, right? Like everything kind of lines up. Yeah, it's very nice.
Yeah. So once I'll probably switch into maybe Visual Studio at some point, or do Atom, so that we can edit the code from there. But at this point, you can see how everything is being generated, and we can go to a point of starting to update these different resources and seeing what kind of data we generate at the end of the day. So let's look at what's inside the controllers. So inside the controllers, we have a suite test. So we have automated testing already built into this. Beautiful. So by the time you build in your code, at least you know, you can of course extend it and say that for this storefront, when doing a test, you should try input these values, and this is what you should expect, and things of the kind. That's so that cool. You have automated testing. But traditionally, you'd write your code, then stop and do the testing to make sure everything works. So this is already good news that you already have some capability for testing built in already. Okay, so we have our storefront here. So the storefront controller. And at this point, we can go ahead and add these resources. Actually, let's look at the role. It probably doesn't have much at this point, but let's see what's in there. Config RBAC. Actually, the whole path is here, so I can just do that.
Nice.
So here we have class role, and it's for the API group store.example.com. You remember when we were creating our API, we said the group is going to be store, and the domain when creating the operator was example.com. So we can see them coming together. And the resource under that API group is storefront. And we can see we have verbs or privileges to create, delete, get, list, patch, update, and watch that resource. And we also have a sub resource for status. So it's storefront/status, and we can get the status. So that is for the editor role. And then if we do a git status, we also had a viewer role. Which one did I look at previously?
Editor.
Okay, that was the editor role. So viewer role.
And I'll say that, I don't know if you mentioned it, Edmund, already, but just a heads up, and it's good that you're showing these too, is that the whole idea here is that, it auto-generated these based off Edmund's storefront custom resource. But the cool thing too is that what we're going to learn is when Edmund's going to show to you later coming up is the markers. We don't have to go in here and touch this stuff. But the whole idea of this is that we don't want to have to go inside these manifests and these files and manually interact with them.
Automation.
Go in here, right?
Yeah.
We're going to show you that coming up. Just to throw it out there. Go ahead. Sorry.
Yeah. So this already shows us, the roles that we would have to be able to view our custom resources. And of course, as we build our operator out, we'll add markers to customize and say this operator should be able to also view deployments or view pods and things of the kind. So we are going to look at how to do that. Okay, so at this point, I would say, I don't know whether we looked at the project file. So let's do a git diff. So the project file would contain the name of the resources. So initially it only had the domain example.com. Of course, it tells us the layout we're using, which is Kubebuilder.io v2. So this is a change from the first project layout for a Kubebuilder operator. The project name we can say is test operator. We did not supply that, but it picked that from the directory name that we had. It picks the repo from the directory structure. So my code, as you can see, is inside my Go directory. We have source, gitlab.com, my user handle, then test operator. So there's a lot of stuff that we did not specify that was automatically picked up. But the key thing here is we have our resources and we have store as a group. The kind is storefront and the version is v1 beta 1. At this point, I may do a quick change to, let's say, an IDE so that we can look at some of the markers and generate a little bit more resources. But before we do that, let's add this. And
now, Edmund, so let me ask you this. If I'm building a project with this for the first time, I'm using the new Operator-SDK, and I haven't used Operator-SDK a long time ago. So a long time ago, I remember it used dep for package dependency management, right?
Right.
Now I see it's using mod. Is there any reason, if I'm not going to import any custom packages, anything out of the usual, is there any reason I need to go into mess around with the .mod or the sum file at all? If I'm not going to add anything, what do you think?
So the Go mod, even in this case, we haven't added any specific libraries for our application, but we do have dependencies that we will need. For instance, we will need uh, client Go to interact with Kubernetes. We will have controller runtime, which is helping us not have to write out a lot of the interactions with our Kubernetes resources. We have uh, Ginkgo and Gomega, which are some of the tools that are allowing us to do tests. So all those files are going to go inside our go.mod. Here, at this point, it's not robust, but we have API machinery, we have client Go, we have controller runtime, and we have logger, which is what we'll be using to log our events or whatever actions are taking place, logging our errors as well. So those would come here. And the GOSUM, what essentially the GOSUM would have would be a checksum or yeah,
Nice.
a checksum with hashes for the different packages. So what essentially this means is if I run this project locally and I send it to you, whether you have these
Mhm.
libraries or not, you'll end up with the same version of code I had, because the Go modules is also going to check that not only the version information in the Go mod match, but also the hash in the GoSum match what is defined in those two files. So
Right.
you end up with consistency with those two files. But if you only send the Go mod, if somebody decided to overwrite, let's say, k8s.io utils, we may have the same version number, but we may have GoSums with different hashes or checksums at the end of the day. But
Cool.
generally, whenever you're adding a module, you may not necessarily have to edit the Go mod yourself. You can do, for instance, go get um, whatever the name of the module is, and once you do that, your Go mod is going to be updated automatically.
Gotcha.
Yeah.
Cool.
Okay.
So right now we have an API for storefront,
Right.
and we haven't looked at the types.go file. That's where it gets real fun. Types.go.
Okay. Yeah. So at this point, I'm thinking Atom will probably give me ease of use from
Yeah.
the perspective of increasing my fonts and things of the kind. So I'll switch to Atom. I'll share that in a second.
Do you use Atom more often, or do you use code more often? Which one
Yeah.
do you
What's
like
your
to use?
preference?
I use code, but whenever doing presentations, I find it difficult to maneuver things in Atom. So for that reason, I would use it for presentations, but not for uh,
Hmm.
Interesting.
not for my development. Okay. All right. I will share my Atom interface here. So share, where is it? Hopefully that is legible. I will increase
Yeah.
the. Okay, so go inside the API directory and we want to update our storefront. Okay, so this is information of how we can update our API, or we should update our API, update the spec here.
Hmm.
So in this case, we are going to say for every store we create, we want to specify size, and that will be a string. We can make it. Wait. I made it a string. We can make it an int 32, and we can say size. That will tell us the size of the store, and we can probably not say omit empty. And omit empty means if it's empty, do not send a value. And then the next thing we can add, actually, it wouldn't hurt anything for us to say omit empty. I'll just do that. And
And where's that? What's that? What is it? What does that mean? That JSON size? What does that mean? What am I doing right there? Because I noticed it says size on the left. So so we're building this. We're trying to build this API, and I'm looking at this size. That's the field, and it's going to be a 32-bit integer. Okay, so that's cool. And then what is that reference? What's that JSON thing there? Why do I have size 2 times? What's that saying? What's that signifying?
Yeah. So good question. And so size, we have 2 values. So when interacting with Kubernetes, most of the resources that you interact with, we interact with them from a YAML standpoint, right? So you create a deployment, you create a YAML. What happens in the background that we don't see, that YAML in most cases would be converted to JSON. And then that is fed to the API. So in essence, what we are seeing, the size on the right is what the user would specify when creating a storefront object. So in our case, let's go into config and look at our samples file. I believe we should have something. So here we can say our sample storefront would have, let's say, a size of 1. And location, we can say our location is SAT for San Antonio. That is going to be our store. So when we send this, once we come to this other file, it's going to say, what JSON file do we have called size? And that will be assigned to this Golang variable called size. So when retrieving the values from our controller, we would not be retrieving this, but we will be retrieving this, the size on the left. So this is just a mapping of what Golang says and what is being passed to us by the Kube API server. Because if you think about it, all the interactions we have would go through Kube API server, then Kube API server would transfer those events to, or persist those events to etcd. And the operator is watching the events in Kubernetes. And when it says, okay, I have an event for a resource I'm watching, in this case, storefront, it says, okay, I need to do a reconciliation and do whatever reconciliation it needs to do. So in this case, we've created two fields for our spec, and we can leave it at that. And so let's look at what has changed from, so from our standpoint, looking on the left tab, we can see we only have 2 files that have changed. I'm going to run make manifests on a terminal, which you may not see, but at the end of the day, we want to come back and see how many files changed after that.
So we're not going to update status. We're going to keep the status as empty.
So for now, we can update status, but for now, I haven't done anything there. We can say, let's say we can say face is string, and we'll just say JSON. All right. And we say face and omit.
And users, and just so people know about status, because I always get a lot of questions on status. People are like, what is status in all Kube objects? Like, well, most use status, not all of them, right? Yeah. People are always like, what is, like, you know, what is that? And the reality is, typically only controllers are touching status, right? The users, humans aren't touching the status. The controllers are reporting status information for the user, or possibly for your controller to see, to know whether or not to perform an action. So you can store some previous old state inside status as well. But users, humans are not touching status, right? Typically.
Yeah, so humans won't touch the status. It's your operator that would touch the status. And that's a way for the operator to send feedback to the user and tell them, this is the state of the object that you requested. Let's say you requested a storefront with, let's say, a size of 3, but we are currently building that. So we can send that as in a status field, or we can tell you, you requested 3, but we currently have 2 of 3. So that is a way to give feedback back to the user.
Gotcha.
Yeah. All right. So at this point, we'll go ahead and generate the manifests. So make manifests.
And that command that Edmund's running right now, make manifests, that used to, when you used Operator SDK before, you would say like Operator SDK generate K8s, right, to generate what are called the deep copy objects.
Right.
And the deep copy objects are because we don't want to, anytime we're building out a spec that uses a reference type, like a slice or a map or something like that, right? You don't want, you have to be careful with that, because when in our reconciler and our controller, when we get that object, we don't want to manipulate or mutate the original object, right? And so the deep copy object does a deep copy for us. And in the past, with old Operator SDK, you'd have to manually run to do that deep copy object generate. You'd have to run Operator SDK generate K8s. Now you just run. You could do make generate, but I believe the make manifest runs the make generate automatically, right, Edmund? I think it does.
Yeah. I believe you're correct on that.
Yeah,
and so we end up with deep copy. And the reason why deep copy is important is most of the objects that you're going to interact with would normally have or implement the interface runtime.object. But without the deep copy function, the custom resource that you created would not be recognized as or would not implement that runtime object. So you may not be able to use the controller runtime functions to create them or delete or do any other manipulations against that object.
Yeah, that's a good point too. So if you don't even run that generate, if it doesn't even generate those deep copy objects, if you're using a reference type in your types that go, it's not even going to work, right? It's not even going to, because it's not going to be able to get that. What is it? What is it? Dot object, or what did you just mention? Object.
So
what is it?
Runtime.object.
Runtime.object, right? Yeah, runtime.object. That's right. It needs deep copy. It needs that those deep copy functions, right?
Right.
Yeah.
And so if we look at your deep copy or this, you normally have under the API, in most cases, you have the zz_generated.deepcopy.go. That is where your deep copy functionality would go into. But it's something that is done for you unless you have a particular reason to look into that. You don't have to. So just don't worry about that at this point. The next thing we'll look at is we ran make manifest. We can see the CRD directory is now lit. It's green, which means there's a change in there, and RBAC directory has changed as well. So let's look at what's in there. So we now have inside the business directory, we can see after making our changes, our CRD now has more information, and we can see for the property. Okay, I will have to find my way around this, but we do have.
Quick question. Matt, can I share the slides from earlier publicly?
Sure, I'll send them to you.
I got them. They're right here.
How do you have the slides? How do you have the slides?
I provided them to.
Yeah.
Oh, thank you. Oh, thank you, Edmund. Thank you, Edmund. I was like, how did you have those?
It's magic.
Oh, thank you. Thank you, Edmund.
I'm the omnipotent Chris Short. Yeah, no.
Yeah.
Edmund gave them to me.
Okay, cool.
So looking at the properties, when defining our specs, we specified or we created size and location. We can see here we have size. And inside our CRD, we're saying it will be a format int32, which is an integer. And we also have location, which is of type string, right? So
So it got that information. It got that from your types.go.
Right.
So it took that information from the types.go. It put that. It saw what you were using those for the types, and then it put that into the CRD. Which, what does this buy me? If I go and I create the storefront object and I don't use a 32-bit integer, it will probably complain, I guess, right?
Correct. If you don't use an int32 value, so for instance, you provide a string instead of putting in the digit 3, you put in you spell out 3, you're going to have an error. It won't accept that because the OpenAPI v3 schema here is doing validation and it's expecting int32, but you provided it something that is not int32. So that won't be accepted at that point, or that whatever you provide would not be persisted.
Right.
And here at this point, we have a CRD which we can persist or apply against our Kubernetes, so that Kubernetes or OpenShift now knows that we have this thing called storefront. But without an operator, it will create a storefront if we provide a custom resource saying we want a storefront with size 3, and it's going to be in San Antonio. It will create the object and persist it in etcd, but it will stop right after that because it doesn't know what to do with that. So the next step will now be to build logic for creating that.
I have a question. What are those little Kubebuilder things? Those comments?
Okay, so the comments here are called markers, and those would be used to dictate what kind of additional stuff needs to be generated. And it also describes or helps to tell the controller tools which objects in your types.go file need to be to have a deep copy function built for. And here we also know, for instance, if you're working with Kubernetes, instead of saying Kubernetes get deployments, spelling out everything, you can say kubectl get deploy. So that is a short name. So you can use markers to create short names. And an example in this case, we can say instead of calling it storefront, which is a long name, we can say we'll create a marker that will define the short name as SF. And we can say we'll have now a Kubebuilder marker that says the resource would have a short name called SF. And this marker has to come right before the main object that you're dealing with. So the storefront spec that we modified is going to be called by the storefront spec that we modified is going to be called into or embedded inside the storefront spec. So we need the Kubebuilder marker to come inside the storefront struct. And at this point, we were looking at our CRD. We can see we don't have any short names, right? So after adding that marker, we can go ahead and do make manifests again and see how the new CRD would show that. And we can see now we have a short name of SF.
Got it.
Yeah. So the markers can allow you to do a lot of stuff that we haven't looked at this point.
Yeah.
And so
basically the whole idea is we don't want to be able to, again, that whole philosophy that we don't want to touch that CRD YAML. We don't want to touch that RBAC YAML, right? We don't want to touch those.
No, hell no.
Correct. Yeah. So we don't attach them. So this gives us a very easy way to change them. And they also come in handy. We'll probably go into Kubebuilder markers later on. But what this gives us is a way to modify our RBAC. It gives us a way to create our cluster service version. We were shown what a CSV is when we were looking at bundles. So that's a huge file too. We can also create some information that goes inside the CSV using markers. And here we've mostly looked at Kubebuilder markers. We can also create what are called Operator-SDK markers. And the Operator-SDK markers may have stuff that Kubebuilder may not have. And here we are talking of resources that may be necessary
Right.
for OLM to be able to manage your operator, right?
Right.
So a lot of the OLM functionality at this point has not been adopted by the Kubebuilder community, but Operator SDK has most of the functionality you have in Kubebuilder, and in addition to that, it has functionality for creating your bundle that would be used by OLM or the Operator Lifecycle Manager to deploy and do all other stuff with your operator.
Cool.
Okay, so
yeah, how do we create a controller now? We have our API.
So
the API,
we have,
I mean, looks pretty good, right? We don't have to add anything else here.
Yeah.
Are we
So
good?
at this point, I think we should be good enough to go ahead and get started. We have our sample, and this was our CRD. I'm trying to find. Okay, let's go into our controllers directory. And where? Okay, here's our controllers directory. And at this point, we do have the storefront reconciler. And this is an object that will pass around when creating functions to interact with the Kubernetes. So it has the client that would be created or provided to us by client Go. And most of the functionality that we're going to interact with directly are going to be provided by a controller runtime. And looking at this here, we can see controller runtime has been imported and has been given a pseudonym of CTRL.
Yeah. One thing I noticed too, I don't mean to interrupt you, I'm just going to throw it out there real quick because people know, is that with the new Kubebuilder, with the new Operator SDK that uses Kubebuilder, when you look at your controller, when you scaffold a project, I mean, this controller doesn't do anything out of the box, as opposed to before. Remember before with Operator SDK, it would give you like some sample code in the controller?
Correct. So the original Operator SDK would create for you an operator that would create one single pod. So at least you had a way to have an idea of what it would look like to create, let's say, a simple operator. But the good thing is, even now with the new approach, there are examples that you can walk through and understand what it takes to build an operator, right?
Yeah.
So not all is lost. We have a different approach, but there's still room for improvement. That is not to be denied. But yeah, this is where we are now. Looking at this, we looked at markers when looking at the types.go, and we also have markers here. And looking at this, we can see they are Kubebuilder markers, and they're specifically for RBAC. So here we have a marker that gives us, that targets the store.example.com group and the group storefronts. And it gives us access to get, list, watch, create, update, patch, and delete a storefront. And we also have another rule here that allows us to act on the status sub-resource, right, for the storefront.
Yeah.
And so in this example, we can say, if we want to, let's say, create a deployment, we'd come and say, this is going to be in the apps group, and the resource is going to be deployment.
Yeah, and so I don't even have to even touch my RBAC here.
Yeah. So
touch my manifest.
Yeah. Yeah. So at this point, if you go ahead and regenerate your markers, let's look at what we have now. So looking at RBAC, let's see what I think that would go under editor role. So far, we don't, no, actually, inside role. So far,
Inside role,
what we
yeah.
have is a manager role, and we have privileges to interact with the storefront resource and the storefront status. So if we go back to our change, and I believe if we do make manifests.
And you're running that off screen, right?
Yeah, the make manifest,
Okay.
I'm running off screen.
Gotcha. Okay. I figured that.
but-
So make sure everything's cut off.
Yeah. Okay. So if you look at this, I just trained make manifest, and now we have a new rule that is targeting the apps group, and it gives us access to deployment. And we can
Right.
take these actions against a deployment.
And make manifest command, if we were to look at the recipe in the Makefile, it's just running the controller gen command tool or controller gen binary, right?
Yeah.
Or doing something like that, right?
Yeah. So I just pulled up my Makefile, and
Yeah.
looking at the manifest target, which I have here, here we have a prerequisite, which is something that would be run before the commands in this target would be executed. In this case, we run controller gen, which ensures that we have the controller gen binary in our path. And mostly it would be installed inside our Go path. And then after that, we do controller gen, and then take any CRD options that have been passed. And then we say RBAC role name, manager role, and provide all this other output. And that will generate the data that we're seeing inside the CRD basis directory, just basically what we were looking at. So here, in case you need to change how certain things behave, you notice an issue, you can come here and change them. So that is totally okay. A good example is here, they're using Docker to build the image. So in my case, just because I do want to have a daemon running on my local system, I use Podman. So I can basically come and say, change this to Podman. And
oh, nice.
Oh,
and,
So
sweet.
you can really
Nice.
customize that.
Wow.
Yeah,
So
you don't have
no
to
daemons
build
needed.
an image or anything.
Yeah.
So, so that is to do with the markers for RBAC and the Makefile. We've jumped around a little bit, but that is a little bit of what you can do. So the first thing when writing your controller before you do anything else would always be to get the main object or the parent object, parent resource that you just created or that your operator is going to watch. So in this case, that is going to be the storefront object, right?
Yeah, and I notice, and you know what I notice here too is that like I'm so used to seeing this file, this before 1.0, there were like it automatically gave me a watch, right? It gave me. I remember there was like it would show me which resources, children resources I was watching, but I don't see that.
Yeah. Yeah. So in this case, the architecture changes a little bit. So in the new Operator-SDK, you don't have the same add method. The add method is what would add which kind of child objects that would be watched. In this case, we have the setup with manager. And basically in this case, we can say this controller, new controller managed by manager for, and that's the parent object, and that's storefront, right?
Yeah.
And in this case, we can say, I believe it's owns or own.
Owns, yeah, that's right.
Owns, and then we say, so we'll need to import the apps v1 API, and that is kate.io/API.
So this storefront custom resource that you created, I imagine that when a user goes and creates a storefront object, it's probably going to create a deployment, maybe?
Yeah, so in this case, what I'm basically getting at is this storefront object will create a deployment, right?
Cool.
So we say this new object that we create, the parent object will watch a deployment, right?
Yeah.
And so we do that. And that means basically this is a good benefit that we're getting from Kubebuilder. So instead of writing that a slightly longer code that we do to add a child resource to be watched, you have a single line basically.
Yeah.
So
Yeah. Because
that is a great benefit.
It is.
Okay.
It is.
Yeah. So here we come and say we want to get our parent object, and going back to the slides that Matt was showing us, for us to interact with an object, we would do r.client let's say get. But with Kubebuilder, we don't have to say r.client. We just say r-get, or with Operator-SDK v1, we say r-get. And in most cases, you'd pass your context here, context.todo or context.background. And instead of doing that, we already have this objects created here that we can use for logging and our context. So in this case, instead of calling context.todo here, I will just say, name this CTX, right?
Yeah.
And do a colon because we're declaring a new object. And this, I will leave that uncommented still as it is, and we'll change it at a later time. So we say CTX, which basically calls context.background. And we can say here we will be calling the object type that we want. So here we'll use rec, and that will be rec dot, I believe it's namespace name. And let's say storefront. So that's where our results would go, right?
Yeah.
So it's apps. So the API and group is store v1 beta 1 dot storefront dot storefront.
Yeah.
And here we come and say storefront. And basically what this means is we will come and request Kubernetes to give us an object. And here the request dot namespace name will provide the name of the object that triggered a reconciliation and the namespace in which it exists. And whatever result we get would be written to this storefront object that we created here.
So that fetches our declaration, right?
Correct. That fetches our declaration or the parent object that we'll be watching.
Parent object, right? Yeah. So and then real quick, the context there where we have CTX value is equal to context.background. So correct. When that's behind the scenes, we can probably imagine that sending some kind of get call, either to the local cache or maybe to directly the API. So context background, is that basically gonna send the call to the background? Is that beneficial to use that context there?
So the context in Golang would allow you to be able to, would allow processes in Golang to be able to interact with each other. So in cases where you have long running processes such as coroutines, sometimes you want one process to check whether another process has finished executing or is still executing or whatever have you, or cancel the execution of a process. If they have different contexts, they cannot interact. So having the same context in that case becomes important. So in this case, we can choose to use CTX throughout our operators so that we can have processes intermingle, if at all we want to call it.
So this is okay. So context is a reference to the process, not necessarily a reference to the actual API call.
Yes.
It's okay. Right. Okay. Cool.
Yeah.
Gotcha.
So context is more so of a Golang primitive or a Golang object versus being specific to Kubernetes. But
gotcha.
Yeah. So in this case, we can say, okay, if you get an error trying to create or to get this object, what does that mean? So, at this point, we can start building out our operator. So if it doesn't exist, then that means there's probably nothing for us to do. right? So in this case, we can say we'll return, we'll just take this. And we can say error. And by returning an error, what essentially happens is the object is going to be, or the whole thing is going to be requeued. And so we may have another opportunity to run again and see whether it exists. And after a few times, we may just stop, retry. But as we go on, we can come back and modify. But in this case, so that we can look at other stuff before coming into operators, we can just get the object that we have and print out information about it, right? So we can say log info. At this point, we haven't specified where this log object comes from, but we name this to log, whatever was already created for us, and we can say returned custom object. And we can say name / namespace. No, let's say I'll just do name for now. And we can say rec dot namespace to name dot name and print that out, so that before we start doing any other stuff, maybe to create a deployment or anything, we just print out the data we are creating so that we see what we are ending up with, right? So I will do, let me just do a quick make manifest, and then I will change my screen to the terminal, and we can try and run some of this stuff and see what we get out of the changes we've done so far.
Okay, and we have about, just to check the, and Chris can check me on this. Yeah, we have about, what, 12 minutes?
Yeah.
Okay, and then if you want to, Evan, go ahead and, maybe if we have a few minutes left, I can go ahead and we can attempt the live migration and see what the little things we have to change whenever we have, feel free to continue on.
Yeah,
it's not even that.
So I'm thinking most of the concepts that we're going to go through next, you'll cover under the migration. So I can stop now and have you do the pod set migration, and they would be able to have a bigger picture of what happens in a migration.
Sure. Yeah, let me go attempt this. We'll do this on the fly and see if we can get it to work out. Yeah, yeah. Thank you very much.
You're welcome.
Let's keep it cool. So let me go ahead and let's do a share here. Give me 1 second. What are we looking at? What are we looking at? Okay. So
the joys of Zoom screen sharing.
Oh yeah. All right. All right. So for those of you who just want to follow along, we're going to be converting the original pod set operator to the new Kubebuilder plugin, a new Operator-SDK 1.0 that features Kubebuilder alignment that Edmund just described to you and explained to you in a really awesome way. So how are we going to do this? Well, let's pull up my environment here. I'm going to go ahead and I am going to run let's go ahead and create a new directory. I'm going to go ahead and call that new pod set operator. Okay. And inside that directory, I'm going to go ahead and run the following command, Operator-SDK init, no more new. So those of you who are used to typing new all the time, like me, no more new. Now it's init. And we're just going to do domain.example.com. And I'm just going to go ahead and put my repo here, because the idea here is that, yes, I will be committing this. And just also to reference my current path where I am in my directory, my Go path. And then next step I'm going to do here is I'm going to go and create I'm going to say Operator-SDK, create API, group equals app. That was my group. Version equals v1 alpha 1, -- kind equals pod set. Or we can even say pod set like that.
Ooh, fancy.
Yeah. a resource and controller. So that means I want to create, let's see what happens here. Let's see what it says. I think that's, because usually it prompts me, right, Edmund? If I don't, it's going to prompt me.
Yeah, so if you don't say -- controller and -- resource, you get a prompt asking you whether you want them created or not.
Right. So basically what I just said here is give me both, right?
Right.
I want the API. All right. So this literally, notice that I didn't have to do the create controller or add controller command here, because I did that, it added for me automatically.
Nice.
So what I'm going to do now is I'm going to go ahead and open up the new pod set operator in code. And we are going to go ahead and let's remove some of this stuff here. Okay, and we're going to go ahead and go to our first things first. Let's go to our API, and actually let's open up a terminal here just so we have that open. Let's go to our API file here. And we all know how the pod set, for those of you who have used pod set before, we know this is 32-bit integer, and we're just going to call that replicas. And then in here in our status, and by the way, if you're wondering where I'm getting this information from, I am getting this from this types.go file here. Okay, same thing. You can see here we have pod names, just like that. Okay, so that's pretty much all we have to do there. Now, instead of running Operator-SDK, just like Edmund shows you, instead of running Operator-SDK, generate K8s and generate CRDs and all that stuff, I'm just going to do a make manifest. Look good, Edmund, so far? Yeah,
looks good.
I think that, yeah. Notice I'm not adding any of the fancy stuff that Edmund had in terms of the markers. Like we know that like with markers, we can add validation information. So if I wanted to, I could put a Kubebuilder tag inside here, right? That basically said something like, if I wanted to, add the capability to do minimum, maximum values, I could do that here. I could say, like, for example, plus, Kubebuilder equal validation, or I could do validation with min values, all that kind of stuff if I wanted to, but we're just doing this quickly. So, all right, so let's do the make manifest. And really it's as simple as that. There we go. We did our make manifest. Now we should, as a result of that, have our CRD, okay, which looks good. It looks like it knew that I was using a 32-bit integer and all that good stuff. Array strings here, looks good. Okay. Controller, where is our controller? So we actually
further down.
Let's go down, 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 and there's our controller. Yep, there it is. And here is the same stuff that Edmund was just showing you, but we're going to show you what happens. What is it going to say when we actually go and grab logic that was created? And by the way, if you're wondering where this was created with, or what this was created with, this was created with, I think it was 0.15.2. Is it 0.15.2?
Yeah,
yeah.
You mentioned 0.15.2, so that sounds right.
Yeah. So if we actually go, and if right off the bat, right, we kind of notice that this is actually using, remember we talked about this long-winded watch for the parent and children objects, this long-winded watch. You notice here that long-winded watch is no longer here. We just have this set up with manager function down here, okay? So right off the bat, what I can probably start doing is maybe thinking, okay, well, what I have here is I know that I have to watch for pod sets, right? But I also have to watch for pods. So let's go ahead and add that real quick. We're gonna have to go ahead and add our child resource or secondary resource, whichever way you want to refer to it. And I don't even know offhand if I actually imported Core V1 here yet. I don't even know if did I import Core V1 up here?
I don't
No.
believe so.
I don't see it, yeah.
No, yeah, I don't see it up here. So we have to go ahead and import Core V1. So let's go ahead and do that. Okay, there it is. There's Core V1.
And you're missing a period and after your owns, yep.
Yep, thank you. Okay. And this is just complaining about me wanting to, describe what this is doing, right?
All right.
Oh, you have an IDE that tells you to do comments.
Yeah. Okay, I'll just put it as a setup with manager. Okay. Specifies.
Very specific. That was good.
Okay.
You didn't need to.
Okay.
Nah.
Okay. All right. And then so let's go ahead and see if we can. So we got that, and let's go ahead and just get our let's get our logic and see what happens here. First of all, we notice that this object that Edmund was talking to you about. Do you notice how like it's changed? Before it was called reconcile pod set. Like they flipped it. Now it's pod set reconciler. Okay, so that's changed there. And then let's go down here, and then here's where here's where the magic happens, right? This is where the actual. Let's go up here. I think it'll be easy to copy this way. So let's go up and grab this. Here, starting with fetch the pod set instance. I'm going to go ahead and see what happens if let's push this down because we know that's taking care of our watch. Let's go see what happens here. So I'm going to drop this logic in right here, just blindly. And I'm going to save it. And you can see immediately we have some issues here that we have to take care of, right? One of the biggest ones, if we actually look for our client that we're using, we're saying r.client.list, right? But all we can actually do here is we just want to call that, I think, r.get, right? So let's just what we could do here is we could do a find and replace, or we could just go ahead and take all the times where we reference r.client. There's an r.client there.
I guess I need my popcorn.
Lightning fast.
Okay. So there, and then listen, and then the other thing too is our request. Notice that our request is called rec, right? We're calling that. So let's go ahead and change that. Okay. And then notice the logger, right? Notice that rec. We're referring to this thing as rec logger here, right? We can just call it log, right?
Right.
Should we be able to call it log?
Yeah. So we may want to instantiate the log object that you have so that, you should be fine.
Let's get rid of those log loggers real quick. And we could probably, we could do, let's see if we can.
Yeah. I learned something new. I didn't know you can do find and replace in code.
Yeah,
really?
It's helpful sometimes.
Oh gosh, it's like my and you can use regex and like selections, and it's like my favorite thing to use.
Good.
Oh man, it's awesome.
I learned
missing
something
out,
new,
buddy.
And then here, let me see. We have
the r.scheme would change from being all lowercase to become r.scheme with an uppercase S.
Yes. Look at that.
Mm-hmm.
Okay. And then it looks like there's one little thing left.
Right. So we may need to import API
v1
machinery.
Yeah. So let's go ahead and do that. Yeah, let's import that. Okay.
Yeah.
So as you can see, there are a few things. But it's not too bad. And let's see if we can get this thing to run real quick. I don't know if are we getting cut off? Or are we
yeah, you got like 5 minutes overhead. I just got to pick up my kid. That's all.
Oh, sorry. No, real quick. Just gonna say
no big deal.
Quick, wait. Let's look at the. Let's see. What is it? Run. Make run.
So,
right?
Yeah, just make run.
And then we obviously need to go and make sure that we have our
kube config.
Yep. Yeah. Or I'm sorry. Git. Where is my thing? 4.4, OCP 4.5, auth kubeconfig. Do I have access to my cluster? Yes, I do. Have I created my, how do I create my, I can just do, go ahead.
So to install your custom resource
yeah, there's a shortcut for that, right? But I was just going to do that manually. What do you think?
Yes, so you can do, I think you can do make manifest and make install. That would install the CRDs to your cluster, and then you can do a make run.
All right, let's try it. So make install.
Yeah.
Yeah. Oh, yeah, it worked. Wow. Okay. And then we want to do make run.
Don't sound so surprised.
I meant not because not because of the code.
No. Like you should have that faith in your skills by now. I feel like, Matt.
I had to figure my cluster is. I couldn't believe it. Actually, I thought there was. You know how you used clusters.
I know. I get it. Yeah.
All right. So it looks like it's running smoothly. It's just sitting there. It's very lonely. It's waiting for the creation of a custom resource, which should be in our samples directory, which you can just try real quick just to make sure. I'll use kubectl. Fine.
Did we already update the sample? I'm not certain we did.
Let's look at it. Good question. We'll just do a quick vim and change that to replicas. 3.
Okay.
All right. Is the magic going to happen? Let's leave enough room. You always want to leave enough room in your controller to see the magic, the reconciling. Oh yeah. And then the kube config line there.
Plastic.
Okay, there. And then we are, just to check real quick, what are we in here? What do we wait? Which project are we in? OC project, OC new.
So yeah.
I'll just create one real quick. Pod set. We're there. Run it. Make sure this person is, it should be the same context. So we're on pod set. All right, here goes nothing. Are we gonna be excited when it comes up? Let's see. Applied.
Okay, we see some logging.
We do see some logging. Moment of truth. Ooh, there it is.
All right.
And are there pods there for it?
Nice.
Yes, there are. And we made sure that is there pod names?
Boom.
Yep. There they are.
Nice.
All right, so there you go. Not too bad, right? For what do you all think?
Yeah.
What do you? Yeah. And Edmund actually legitimately updated a live operating project, a live operator project. And had you find it pretty easy, Edmund? What do you think?
Yeah, it's pretty easy, and of course, having experience with Operator-SDK Preview 1, I had a lot of background, so I always draw from that. But it's straightforward, and just find, if you're new to operators as a whole, find documentation and examples, and follow that, and you should be able to achieve it.
Awesome.
Sounds great.
Well,
thank you both so much. This has been so informative. You've got comments and appreciation in the chat stream. This is awesome. Shared so much info. Also, Matt dropped it in chat earlier, but there is a survey. If you are using Operator-SDK, we want to hear from you. I'm going to repaste it just to make sure everybody sees it. But this would vitally help us understand who all is using Operator-SDK, who all we can invite to kind of help bolster it, contribute to it, and better maintain the community of Operator-SDK users. So yes, please fill out this survey and let us know if you're using the project, modifying the project in any way, shape, or form, forking it, whatever you're doing. Let us know.
Yeah, whatever issues you've seen, let us know.
Yeah, for sure. I'm going to drop in real quick into the Twitch. I'm just dropping in the upstream document. Do we already have, I think we've already dropped in a link to that.
You might as well go ahead and drop it in again. It's not going to hurt anything.
Yeah.
There you
Yeah. Everything you need to know is on there, as well as other resources like chat, Slack on upstream Kubernetes Slack, and good stuff.
Awesome. Yeah. No, there's plenty of places to get help with operators if you need it. So please follow the resources. Go to learn.openshift.com and you can learn how to use them today. And yeah, anything else, guys?
No, I think we're good.
Yeah, nothing new from me.
Awesome. This is a great show. Thank you so much for joining us. So let's see. Tomorrow is Friday. We have an OpenShift Commons briefing, adoption adventures south of the equator. Not sure what that means, but Santiago, I can't say his last name, Senelkov will be on from Red Hat. So that'll be great to see at noon tomorrow Eastern, 1600 UTC. All right. Thank you both for joining us, and I'll talk to you both sometime in the near future.
All right. Thanks
Yeah,
for having us.
thank you.
Thanks for having us.
It was a blast.